Something strange is happening beneath Yellowstone. Satellites have spotted glowing red lines spreading across the caldera, and the park has suddenly been closed to the public.
It's a popular summer destination for families, but right now all entrances to Yellowstone National Park are closed.
Something unprecedented is happening beneath America's most iconic national park. For decades, Yellowstone has been the land of geysers, steaming vents, and tranquil wilderness, a place where nature's power seems tamed, predictable. But now, satellites are detecting something that scientists have never seen before. A network of glowing red deformation lines spreading across the caldera's surface, and the park has been abruptly closed to the public. Officials are calling it a precautionary measure, but behind closed doors, geologists are scrambling to understand what the satellite data truly means. According to a leaked report from the USGS Yellowstone Volcano Observatory, high-resolution radar satellites have detected rapid uplift and linear ground fractures, stretching for miles across the northwestern edge of the caldera. On radar maps, those zones appear as thin red lines, regions of sudden deformation where the Earth's surface has shifted by several inches in just days. At first, analysts thought it was a data glitch. Then, new passes from ESA's Sentinel-1 and NASA's NISAR satellites confirmed the same readings. The deformation wasn't an illusion, it was spreading. Within 48 hours, park rangers began reporting new steaming vents, unusual sulfur odors, and the closure of roads warped by rising ground near Norris Geyser Basin and Hayden Valley. Tourists described the air as metallic and electric, while thermal cameras picked up expanding heat zones never recorded before. So what exactly are these red lines? In technical terms, they represent phase shifts in radar interferometry, the result of vertical motion between consecutive satellite scans. But to volcanologists, they mean something far simpler. The ground is moving. And not just a little. Over the past 2 weeks, sections of the caldera have lifted by as much as 6 centimeters, while others have sunk, creating a distorted patchwork of strain, like a balloon inflating unevenly. The pattern is unlike anything ever observed at Yellowstone. Scientists are divided. Some believe this could signal a massive intrusion of new magma, forcing the surface upward as molten rock pools miles beneath the crust. Others think it might be superheated hydrothermal fluids rising through fractures, releasing pressure in unpredictable bursts, the kind that can trigger explosions without warning. The Department of the Interior confirmed late Thursday that all park entrances are now closed, due to unusual ground deformation and safety concerns. Helicopter flyovers have been restricted, and drone surveillance is ongoing. Dr. Alicia Morgan, a geophysicist with the USGS, described the situation as highly unusual and potentially significant. She added, "We've seen uplift before, but never this fast, never this organized. It looks like the crust itself is flexing in real time." The last time Yellowstone saw similar unrest was in 2004 to 2010, when ground uplift near Norris Basin reached historic levels before subsiding. But this time, the deformation is larger, faster, and aligned in geometric patterns. Straight lines where the surface has fractured under stress. What's forming beneath the park? Could it be a new fault network? A magma intrusion? Or something far more complex? The rearrangement of Yellowstone's entire hydrothermal system? No one knows for sure. What is certain is that something deep within the caldera is pushing upward with enough force to reshape the land itself. For now, Yellowstone is silent, eerily silent. Trails are empty. Geysers hiss in the distance. The world's most closely watched supervolcano has been sealed off, and satellites continue to record the spreading red scars that mark the surface. Is this just another episode of volcanic restlessness? or the prelude to an event beyond anything modern science has ever witnessed. The images tell a story that no one can yet explain, and if the satellites are right, the story may just be beginning. Chapter 1: A Park on Edge. Something strange is happening at Yellowstone, and it's not the kind of change you can see from a boardwalk or a camera lens. Beneath the calm forests, the steaming pools and the postcard views, the ground itself is beginning to twist, stretch, and rise. The world's most famous supervolcano spans nearly 9,000 square kilometers across Wyoming, Montana, and Idaho. It looks peaceful from above, a vast basin of geysers, hot springs, and ancient lava plains. But deep below lies a colossal magma system, powerful enough to reshape the entire North American continent. For years, Yellowstone's pulse has been predictable. The caldera rises and falls like slow breathing. Magma shifts deep below. Gases vent harmlessly through geysers. But recently that rhythm has broken. The breathing has become uneven, faster, sharper, unpredictable. Clusters of earthquakes have begun swarming around Madison Plateau and Norris Geyser Basin. Hundreds of microtremors, too weak to be felt by visitors, but strong enough to light up the sensors. Gas monitors show dangerous spikes in carbon dioxide and hydrogen sulfide, both signs that something below is heating up. Then came the geysers. Dormant springs erupted without warning, some venting with pressures unseen in decades. Pools once calm and turquoise turned cloudy, churning violently. Steam now rises thicker, heavier, tainted with the metallic scent of sulfur. From the air, Yellowstone still looks calm, but the numbers tell another story. Radar satellites have detected abrupt vertical motion near the northwestern rim of the caldera, a sharp, localized uplift, instead of the gentle, round bulges normally seen in stable phases. The ground is no longer moving randomly. It's moving in lines, deliberate, geometric, unnatural. Boardwalks are warping. Roads between Norris Junction and Mammoth Hot Springs are twisting and cracking. Photographers comparing images just weeks apart are finding faint ridges and linear fractures appearing where there were none before. Even the soil itself feels hotter beneath the surface. The park's rangers describe it as if Yellowstone's skin is tightening, stretching over something rising underneath. Pressure gauges in Hayden Valley are fluctuating wildly. Some thermal pools have climbed 5 degrees Celsius in temperature in less than a week. Fumaroles louder than ever, spitting bursts of steam that leave the air metallic and sharp. Late one night, a deep vibration rolled through the Gibbon River Valley. It wasn't an explosion, it was movement. Instruments confirmed a low-frequency tremor lasting nearly 90 seconds, the kind that only comes from energy deep within the crust. To the naked eye, Yellowstone is still beautiful, still silent. But below the surface, it's restless. Something is shifting, something massive. Because this time, the real warning didn't come from the ground. It came from space. Chapter 2: The Satellite Discovery. It began with a flicker of color on a satellite map, a strange anomaly glowing deep in the heart of America. When analysts processed radar data from NASA's NISAR satellite, they saw it clearly. Thin, red lines cutting across Yellowstone's caldera, stretching for miles through the crust. At first, it looked like a glitch, but then came confirmation from ESA's Sentinel-1 satellites, viewing from another orbit. The same red fractures, in the same places, at the same scale. The odds of error were zero. The ground at Yellowstone wasn't shifting randomly anymore. It was organizing. The deformation didn't form a dome as it had in past uplift cycles. It was linear, patterned, and spreading in all directions, as if the Earth itself were tearing open along hidden seams. Each red line represented vertical motion, zones where the surface had risen several centimeters in mere days, and new ones were appearing with every orbital pass. The satellite data revealed a growing lattice of strain connecting the park's ancient fault systems. Fractures buried for hundreds of thousands of years that were now waking up together. Soon, thermal satellites joined in. Landsat 9 and EcoStress recorded heat flaring along the same coordinates. Dozens of hotspots ignited in perfect alignment with the radar lines. The match was undeniable. Deformation and heat moving in sync. Yellowstone's crust was responding to a single, unified force, something pushing upward with alarming precision. From orbit, the caldera resembled a living network, its veins glowing through the Earth's skin. Every 12 hours, the pattern pulsed brighter, wider, and more symmetrical. Ground instruments confirmed what space had already shown. The surface was now rising 2 centimeters per day, while the fractures spread east toward Hayden Valley. This wasn't slow geological change. It was an instant reaction, the kind of movement that usually takes centuries, now unfolding in weeks. The satellites had captured something never before recorded, a volcanic system acting not in pieces, but as a single organism, its crust moving in unison under enormous internal pressure. For the first time, Yellowstone wasn't being studied from the ground up. It was being watched from space down.
Chapter 3.
Ground Truth. When Yellowstone suddenly closed, no one knew the real reason. Only a handful of specialists entered: geologists, drone crews, and seismic engineers, tasked with confirming the terrifying data satellites had already revealed from space. The moment they arrived, the evidence surrounded them. Boardwalks at Norris Geyser Basin were warped. Steam hissed from new cracks slicing through the earth.
Ground that had been stable for decades now bulged upward, the soil bending and shifting under invisible pressure. The air shimmered with heat. The surface was literally changing shape. Thermal imaging exposed the scale. Fields that once cooled at night now glowed in bright infrared, tracing perfect linear scars, the same red fractures spotted from orbit. In Hayden Valley, drones recorded straight fault corridors stretching for kilometers, the crust splitting along a geometric grid, as if the land itself were being pulled apart. Gas sensors confirmed what the eyes could already see. Carbon dioxide levels had tripled. Hydrogen sulfide, a gas born from magma, was leaking near the surface. In some areas, ground temperatures exceeded 90 degrees Celsius, hot enough to melt rubber. Below the surface, the readings were even more alarming. Hundreds of low-frequency tremors pulsed beneath the northwestern rim. Slow, resonant vibrations that signal molten rock and superheated fluids on the move. Within days, the tremors linked together in an arc that mirrored the satellite's deformation map exactly. From above, thermal drones revealed glowing dots forming across the park. Dozens of newborn vents appearing along the fractures, spreading fast. The pattern looked less like geology and more like a living system expanding outward. To visitors, Yellowstone still seemed calm. The forests were quiet, the skies clear, but underfoot, the earth was breathing, hot, unstable, and alive. Chapter 4. What lies beneath? Beneath Yellowstone's calm lakes and pine forests lies one of the most dangerous structures on Earth. A towering system of molten rock capable of reshaping continents. For decades, scientists have mapped fragments of it using tremors and radar. But the new data reveals something no model ever predicted. Seismic imaging shows that Yellowstone isn't a single magma chamber. It's a stacked network of reservoirs, stretching from the shallow crust down nearly 45 kilometers into the mantle. The upper zone fuels the geysers and hot springs visitors see on the surface, but the deeper chamber, massive, dense, and volatile, connects directly to a rising column of magma from the Earth's interior. That column, or mantle plume, is Yellowstone's engine. Normally, it pulses slowly over centuries, but now, its rhythm has accelerated. New tomography shows magma rising fast, intruding into the upper crust. And it's not ordinary magma, it's rhyolitic, thick, gas-filled and explosively unstable. The mysterious red lines seen from satellites now make sense. They trace the pathways of intrusion, molten rock forcing through fractures, reshaping the surface as it climbs. Gravity readings confirm that the crust is losing density, replaced by new melt. Each underground pulse bends the surface like glass under strain. Thermal cameras show the result. Entire valleys warming, geysers venting superheated steam, and soil temperatures rising in perfect alignment with the satellite deformation. The park's natural pressure valves, its water systems, are struggling to contain the surge. If the magma continues its ascent, the crust could fail under pressure, triggering hydrothermal explosions or something far worse. For now, the surface holds, but the signs are unmistakable. The earth beneath Yellowstone is reorganizing itself. Every tremor, every fracture, every flare of heat marks the same unstoppable truth. Something vast and ancient is moving upward. Yellowstone isn't simply waking up, it's rebuilding itself from below. Chapter 5. Crisis at the Caldera. The Yellowstone Plateau was no longer stable. Not from the ground, not from space. What began as scattered deformation had evolved into a perfect ring of uplift encircling the entire caldera, visible in every satellite pass. The once localized red lines had merged into a glowing halo, expanding outward as if the park itself were inflating from within. GPS stations confirmed the impossible. Some areas were rising nearly 2 centimeters per day, while tilt meters pulsed with irregular waves of pressure, hinting that the crust was flexing under massive strain. Infrared satellites revealed the thermal consequences. Valleys that had been frozen for centuries now radiated heat like furnaces. From orbit, the caldera glowed crimson, a living circle of energy widening with every pass. On the surface, the transformation was undeniable. Roads buckled, soil cracked open, venting steam and sulfur. Rivers turned cloudy with minerals released from the depths. A constant low hum vibrated through the air, the sound of a restless planet. Thousands of tremors rippled through the crust. Not sharp quakes, but deep, rolling vibrations that spoke of magma in motion. Geothermal basins began erupting violently. Fumaroles roared, springs overflowed, and new vents tore through the earth along the same expanding ring seen from space, reorganizing under pressure on a planetary scale. Every 12 hours, the red ring grew brighter and thicker, a pulse of heat and motion, spreading farther with each orbit. The world's most powerful volcanic system was no longer resting. It was reawakening, piece by piece, breath by breath. Chapter 6. The debate among scientists. As the red ring widened across Yellowstone, scientists realized they were watching something entirely new, a process that defied every volcanic model ever written. The most monitored volcano on Earth was rewriting the rules in real time. For decades, Yellowstone had followed a familiar rhythm: slow uplift, minor quakes, gentle release, then silence. But this time, that rhythm had collapsed. The system wasn't breathing, it was accelerating. Around the world, supercomputers ran non-stop simulations, but the results refused to agree. Some pointed to a massive magma intrusion, molten rock surging upward through the crust. Others blamed hydrothermal overpressure, superheated water expanding until the crust itself began to crack. A third theory was even more disturbing, that the entire continental plate was bending under the rising heat of the mantle plume below. Each explanation carried consequences that reached far beyond Yellowstone. If magma was climbing, a new eruptive phase could be building. If hydrothermal forces were dominating, chains of violent steam explosions might rip through the basins. And if the crust itself was flexing, the resulting stress could ripple outward across half of the United States. The data only deepened the mystery. Gas emissions were high but inconsistent. Thermal zones kept expanding, yet no major vent failed. Deep seismic waves slowed, evidence of melting, but the upper crust remained locked and rigid. The stress lines didn't fade, they migrated, creeping outward across the caldera like a slow clock counting down. Every dataset added questions instead of answers. Every new satellite pass revealed motion too complex for even advanced models to track. For the first time, the monitoring instruments built to understand Yellowstone were too slow to keep up. No one could agree on what was happening beneath the park, but all agreed on one thing. Whatever was driving this transformation was growing, and the Earth was just beginning to feel it.
Chapter 7. What comes next? The satellites haven't stopped watching. Every orbit brings new data, new maps, new flashes of deep red that stain the surface of the Yellowstone Plateau. The ring of deformation has not collapsed, and it has not cooled. Instead, it expands in pulses, slow, rhythmic, like the heartbeat of something enormous stirring below. The numbers refuse to stabilize. Uplift continues across multiple sectors. Seismic noise deep in the crust grows louder and more chaotic. The gases that rise through the vents are no longer stable in composition. Their chemistry shifts day to day, suggesting constant movement in the pressure zones beneath. The crust, once thought solid and predictable, is flexing like the surface of a living organism. Some scientists call it a geological reset, a massive reorganization of one of Earth's most complex volcanic systems. Others see it as a warning, the early tremors of a new phase in Yellowstone's ancient cycle. The truth lies somewhere in between. This is neither eruption nor calm, but an unstable balance that could tilt in either direction at any time. The most recent thermal scans reveal something even more unsettling. At the center of the caldera, just north of the old eruption scar, a new zone of deep heat has appeared. Faint at first, then intensifying over the course of days. It does not correspond to any known vent or geyser basin. The temperature readings suggest the crust there is thinning, a sign that magma is moving closer to the surface, testing its boundaries. From above, Yellowstone looks quiet. Forests blanketed in mist, rivers winding through open valleys, no eruption, no chaos. But beneath that calm, the pressure is relentless. Each tremor, each flicker of red on the satellite feed is a whisper from the Earth's interior. The world's most famous volcano is not erupting, but it's reawakening, reorganizing, realigning, and gathering energy. The scientists studying it admit one thing privately: they don't know when or how this phase will end. The data points to rising activity, yet the mechanisms are still a mystery. Yellowstone is rewriting the rules in real time. What's happening now could fade quietly, absorbed by the planet's deep circulation. Or it could mark the start of a new era of volatility, a chapter in Earth's story that will be studied for centuries. For now, all anyone can do is wait and watch the signals. The satellites will keep orbiting, the sensors will keep listening, and beneath the forests, the magma will keep moving, slowly, silently, relentlessly. Because when Yellowstone changes, it doesn't announce itself with a sound. It shows itself from space,